Part 2 of the International Pearson's Edexcel M2 paper, June 14, question 5. It's an impulse question. They do like to try and think of different kind of angles, no pun intended, for questions, and they try and mix it up a bit. This time we're given the fact that it's going at 12i and it's subject to some impulse coming up in this direction. Okay, and then obviously as a result of that impulse it's going to have some speed, 15, and we don't know the angle. Just tells us the speed, so we don't know the components of it. But given this scenario, we know the mass is 0.5 as well. We should be able to find out the value of k that would result in a speed of 15, because we know the speed is initially 12. Now the mark scheme, if you look at find an Edexcel mark scheme, they split it into components and they call this 15 cos theta and 15 sine theta, and look at it that way. I'm kind of going to avoid that way and just call work in vectors and call the final velocity v with a little squiggle under it so that we make it clear that that's the velocity afterwards. So if I use the impulse equation, okay, let's just do this. So let's leave that there. I think it might be. So it's going from there to there. Okay, so if I use the impulse equation, which is that basically, the impulse is change in momentum. We have k I plus kj is equal to 0.5 v. Remember, that's the components of it. It's not 15. It's whatever the magnitude of it's 15, but we don't know the direction. Take away 0.5 times u, and u we do know the direction because it's 12i. You've got magnitude 12 as well because it's only going in the I direction. Okay, so looking at that and rearranging, I've got 0.5v is equal to ki plus kj plus 6i. If I double that and rearrange, I get v is equal to k plus 12 times by I, because I'm bringing the k and the 6 together and doubling it, because well, it would be 2k of course. Okay, 2k plus 12 I plus 2k j, rearranging that and tidying it. Now, let's say I'm now going to use the fact that the modulus is 15. So that gives us that 2k plus 12 squared plus 2k squared equals 15. So multiplying this out carefully, we get 4k squared plus 48k plus 144 for that bit, plus 4k squared equals 15. Oh, it's not 15, is it? It's going to be the square root of that will be 15. So that will be 225. Do be careful. Okay, so 225. So that gives us 4k squared, 8k squared, should I say, plus 48k minus 81 equals 0. Now solving that, so we can all solve a quadratic equation. I'm putting it into my fx991 ES plus as we speak, because I don't want to be demonstrated in formula. We've got the only viable solution there is k is 1.37 to 3 significant figures. Okay, so that's our value of k. That's part A done. Okay, without having to look at angles particularly, but we're going to have to. It wants the actual angle that this is going at now. So well, let's work that out now. V is, if I sub the value back into there, I'm going to get V equals, so that's 2 times 1.37 and all the rest of it, plus 12. I've got that as 14.7 approximately, 3 significant figures I, plus 2 times that number, or that 1.37 number, which is 2.746 J and all the rest of it. So I've basically got my V going in this direction, with this being 14.7 and this being 2.746, and so I've got the numbers accurately in the stored in my calculator. So that's tangent theta is equal to 2.746 over 14.7 blah 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 as well. So that's inverse tan of that. That gives me 10.6 degrees to 3 significant figures. Okay, slightly different if those you look to the mark scheme, to what they've done in there, but it was quite a neat way of doing it. Okay, so that's question 5, I think, done. Okay, let's have a look at question 6 now. Okay, question 6 is a collisions question. We've got 3 particles. It says that they're initially at rest, but then one of them is going towards it, is given a speed of u. That's the P particle, it's got mass 3m. This is at rest, that's Q is at rest at unknown mass, Km. And R is also at rest. So obviously after the first collision, let's call this one V1, this one V2, that's for P and Q. And of course R is still not moving. So let's do our conservation of linear momentum equation first. The speed, first of all, is 3m is u, so it's 3mu is the momentum, and then is equal to 3mv1 plus kmv2, and of course the m cancels to just give us 3u is equal to 3v1 plus kv2. Right, okay, now we can also, as is often normally the case in this, do a Newton's law of restitution equation where, and we're given that the between P and Q, the coefficient of restitution is 1/9. Okay, so that means the coefficient of restitution is speed of separation over speed of approach. Now, so that's 1 over 9, because we're given that number 1 over 9, is equal to speed of separation. Well, these are going to go apart from each other. V2 is going to be the greater of the two. So V2 is going to be greater than V1. We always need to, when we're using this equation, we always must have the top and bottom positive. Okay, it won't do if you wrote V1 minus V2, it's all going to get messed up. So we must make sure that it's positive on top. And then obviously on the bottom, Q is not moving, but P is moving towards it at speed U. Okay, let's write that out. We've got V2 minus V1 is equal to 1 over 9U. So we've got our two equations here. Now let's see what we're being asked for first of all. Show that the speed of Q, that's V2, is what we're after first of all. So we basically want to substitute for V1 or add V1. If I times this by 3, I'm going to get 3V2 minus 3V1 is equal to 1/3 of U. So I'm going to GCSE style number these for, that's number 1, that's number 2. So I'm going to add 1 and 2. Okay, so add 1 and 2, and we get obviously the left. When I add this bit to this bit, the V1 is going to disappear, and I'm going to get KV2 plus 3V2 is equal to 3U plus 1/3 U. So that gives me K plus 3V2 is equal to 10U over 3. So V2 is equal to 10U over 3 K plus 3 as required. Okay, let's have a look at the next part. For the next part, we really need to work out V1 because it starts talking about the direction of P. So we're going to need to find what V1 is, but we've worked out V2 in terms of K, and we've got V, and we can easily work out V1. If we look at this equation here, V1 is equal to V2 minus 1 over 9U. So that equals to 10U over 3 K plus 3 minus 1 over 9U. Let's put that over a common denominator. We get that as 10U over 9K plus 3, times in that by 3. So that's going to be 30, of course, on top. So I've got that over a common denominator minus U over 9K plus 3. And of course I need a K plus 3 on the top there. So that gives me, if I multiply all that out, I get 27U on the top minus UK is equal to 9K plus 3. It looks like a 9K that, doesn't it? So UK, let's make that, so U27 minus K is 9K plus 3. Now let's just think about what I've just done. I've just worked out an expression for P, assuming it's not reversed. Okay, so we, if the motion is reversed, then V1 is less than 0. So that basically means, because U and K plus 3 is definitely not less than 0, neither is U, neither is 9, that must mean that 27 minus K is less than 0. So that must mean that K is greater than 27. Okay, So that's that question done. Let's move on to part C. Okay, so now it gives us the value of K. So we know what V2 is and we know what V1 is. And in fact, it's not reversed because we know that V2 is worked out. We're given it K is 7. So that must mean that V2 is equal to, going back to our expression for K, 10u over 3 times 7 plus 3, which is equal to u over 3. I'm not actually sure if we actually need to evaluate V1 here, because it's not going to catch it up, and it talks about a collision of Q and R. So I reckon I might probably don't need it. So we can do another diagram. This is going with speed u over 3. Now this is our particle Q now. R, remember, hasn't been touched yet because this is a second collision. We now know the mass of Q because it's 7m. And we were given the mass of R in the first place, which is 7.5 m. Now, I think there's some other information we're given here. And that Q is brought to rest. So that means our after situation is going to be 0. And let's call this V3. So conservation of linear momentum again. Quite a nice simple case of this. We've got 7mu over 3 is equal to, because there's this one's stationary, so no momentum there. And now in the after situation, this one is now stationary, so it's just 7.5 m v3. Obviously the m cancels, and we get 7u over 3 is equal to 15 over 2 v3. Which gives us that V3 is equal to 14 over 45 U. Right, so now let's just make sure we answer the question correctly, because often they talk about the total kinetic energy lost throughout both collisions, but here it's only the collision between Q and R. So the KE lost is going to be the initial KE, which is equal to our half times 7m, half mv squared, just in case you don't know the formula for kinetic energy, half times 7m times u over 3 squared. That's the speed of Q before, and R doesn't have n, isn't moving, and then afterwards it's half times 7.5 m times by u over 14 over 45 u squared. And breaking all that down, that gives us, comes to 7 over 270 mu squared. Okay, so that's question 6 done. Let's have a look at the final question 7. So this is projectiles. They've put a bit of they've forcing us to use energy, because there's we've not really used much of the work energy principle here, so they probably thought they'd put that in. And it is the easiest way of doing this. Now, the first thing, you might be initially confused here, because it talks about a speed of 4 and a speed of 7 afterwards. Now, if you think about it, that can only happen in a situation where it's doing this. Because when we're above the line there, the speed is only going to be less as it's moving up, because it's actually it's gaining in gravitational potential energy, but losing kinetic energy. So it's only when it starts going below that point there that it's going to gain kinetic kinetic energy. So let's call that H. Okay. And so this is our 4, and then it's going to move to 7. So we're going to use energy. If we look at the kinetic energy at the start of this motion, we've got that as being equal to half m times 4 squared. Right, now that's going to have equal to, that's going to be equal, if we call this our zero potential energy, we also can add on the gravitational potential energy from there. So that will be equal to mgh. And that will be equal to the kinetic energy, because we'll, at the end, because we're assuming that, well, not assuming anything really, I'm making this my 0 at the bottom here, so it's having no gravitational potential energy at that point. Okay, so m cancels. That's 16 over 2, so that's 8, plus GH is equal to 49 over 2. So GH is equal to 49 over 2 minus 8. So, and that's equal to 33 over 2. So H is equal to 33 over 2g. Okay, and if I work that out, that's equal to 1.7 meters to 2 significant figures, which is probably what we want to give because of the use of g. Okay, so that's part A. Nice, easy 4 marks, if you didn't get confused by the fact that it had to be below. Didn't get mixed up. Right, they've actually also done something a bit different here by talking about the minimum speed. They're expecting us to realise that at the top, the minimum speed will be, because the horizontal speed is constant, the minimum speed will be when it's at the top there, and it will be 2.5. So the minimum speed must be the same as the horizontal speed, because that bit's constant. So in other words, when vertical speed is equal to 0, because it's always going to have that horizontal speed, so it's the vertical speed that's variable. So the minimum speed will be when the vertical speed is 0. So where the horizontal speed is the same as the minimum speed. Okay, so that must mean, if we go back to our situation here, it says it's projected with speed alpha. So now we've got this as 4 and this as 2.5, and we've got alpha. So we've got cos alpha is equal to 2.5 over 4. So that equals to, I'll work that out, inverse cos that gives me 51 degrees. Cos alpha is equal, I've written that strangely, haven't I? Is equal to 2.5 over 4. So alpha is the arc cos of that, which is 51 degrees. Okay, so that's question B done. Now we want the question, what the question is looking for is the horizontal speed distance between A and B, this horizontal distance between A and B. Okay. So I think we're going to need to work out the time taken, and then once we've worked out the time taken, we can just times that by 2.5, which is the horizontal speed, and then it should all work out. So let's just, well, there's a variety of ways of approaching this. Well, let's look at it. What do we know? We know that the vertical speed is equal to, well, it's actually going to be, the vertical speed here will be equal to 4, this bit, the vertical speed here, we can work out easily, that vertical speed, the initial. And that will be useful because we can then start applying some appropriate Suvat equation, but we need the vertical speed in order to do that. So vertical speed is equal to, when using Pythagoras, 4 minus 2.5 squared. 4 squared minus 2.5 squared. So that's, okay, squared. So that's the square root of 39 over 2, which I'll store the exact. It's actually equal to 3.122 and so on to 3 significant figures, or 4 significant figures, but we don't want that yet. Right, so now we know the vertical speed. We also know h, which is that. So I'm going to use s equals ut plus half at squared. So that gives us that, let's just make some room here, s equals ut plus half at squared. We know that it's gone below the point of projection here. So we need that to be minus 33 over 2g, that's usually the exact one, is equal to ut. So u is the square root of 39 over 2 times t, minus 4.9 t squared. Okay, so putting that into working that out and tidying it up, I get 4.9 t squared minus the square root of 39 over 2t minus 33 over 2g equals 0. Right, now I'm going to put that, I'm going to solve that, just put it into quadratic formula. So t is equal to minus b, so it's square root of 39 over 2. It's going to only be the positive one here. The negative one will make it, will be a negative value, which will correspond to the time below here. So you'll see that it's negative. So I'm not even going to bother it writing it in. Square root of b squared, so that's 39 over 4, minus 4 times a times c. So that's, actually this is g over 2, isn't it? So it's 4, and there's going to be 2 negatives, so it's going to be plus 2g, I think that's going to be plus 33 when we work that out, all over 2 times 4.9, which is 9.8. Okay, so I'm probably making a meal of this. You can put in your FX991 ES plus to check the answer. That comes to a value of t of 0.986 plus some more stuff. But remember, we wanted to work out the horizontal distance. So that will be equal to this 0.986 times by the the 2.5. So that equals to two significant figures, 3 significant figures, 2 significant figures is 2.5, or if you give 3 significant figures, it's 2.46 meters. Okay, if you done it that way. Okay, it's not the only way of doing it, but it seems like a reasonably nice way of approaching the problem. And that's it. That's the paper done. I thought it was probably on balance slightly easier than the previous year. Okay.